So mine is on Bokan.
Okay, I think we're ready to get started. So hi everyone. For those of you that don't know me, my name is David Bokan. I work at the Google Waterloo office, and I work on scrolling, viewports, and input. And so today I'm going to be talking about removing blink scrolling. So what on earth do I mean by this? So you might have seen this referred to as scroll unification. There's a detailed design doc that sort of goes over a lot of this, and this talk is mostly going to be rehashing some of this and maybe update it a little bit. And this really goes back to a bug we've had since about 2015. And it's mostly about code health. It's about removing duplication and improving the division of responsibility between the compositor and Blink. The title is a little bit provocative here. So we're not actually removing all of scrolling from Blink. Blink will still know about scroll offsets. JavaScript, nothing really changes there. But this is really about removing the user-initiated scrolling paths from Blink, so all the gesture handling. So before I dive into what kind of changes I'm proposing and how it all look, it'd be useful to kind of get on the same page of how everything works today. So if we go back a number of years, back to the beginning of Blink or back in WebKit, scrolling was quite simple. There was no compositor yet at the time. Basically, anything that scrolls on your page would get a scrollable area. So this is things like your main window, obviously, overflowing divs, iframes, but also things like input controls, like text areas and things like that. So what happens is you would get an input, like if you tick your mouse wheel, you'd get a mouse wheel come into Blink. It would process that, determine that you need to scroll by some number of pixels, and you'd update the scrollable area. Sometime later, Blink would go and produce a new frame, and it would use the scroll offsets from the scrollable area, and that's how you effectively scroll. And so this path still exists in Blink today. So obviously, there's a downside to this. We really want to have low latency responsive scrolling. This is especially important if you're using touch. You really want things to stick to your finger. But there's lots of things that can happen on the Blink thread. We're running JavaScript, we're doing layout and paint and all these things. And they can take an arbitrarily long amount of time and happen at random times. So a busy thread can lead to really janky scrolling and a poor user experience. So we threw in some parallelism, and the Chrome compositor was born. And with it came a new thread. This is the impl thread, and the compositor manages this thread. So the idea here is that we take some of those scrollable areas from Blink, and we composite them. And what it means to composite a scrollable area is that we'll actually render more than just the visible area of the content. We'll actually take some bits around the viewport. We'll render all those, ship them over to the compositor, and then the compositor can scroll those off thread just by translating the layer. So whenever things change in Blink, we need to push those changes to the impl thread, and that's what we call a commit. But basically, you'll notice now we can also handle user input on that impl thread, which means that if nothing changes in Blink, you don't have to do a commit. You don't have to go back to that busy main thread, and then everything is nice and smooth at 60 pips. So we also need to talk a little bit about how scrolling events work here. The main thing to know, there's two kinds of events. There's input events and gesture events. So I'm talking about mouse wheel here, but this applies equally to touch. So when you tick your wheel, we'll first send an input event, and this goes directly to Blink. The compositor doesn't really know or care about that, this one. And this basically just gives the content in the page a chance to override our default scrolling behavior. So for example, if you've got some kind of a widget on your page and you don't want it to scroll around, you would call prevent default on your event. And so then when we act that event back to the browser, that tells it not to do any scrolling. But if you didn't call prevent default, the browser will now need to do a scroll, so it'll generate a gesture event. This would be like a gesture begin, gesture scroll update, and so it sends that back to the renderer. Once it gets to the renderer, the compositor will actually get first crack at it, and if everything goes well and the compositor can handle it, then we basically just act back to the browser, and Blink doesn't have to know about this gesture scroll at all. We'll eventually tell it about the scroll so we can generate JavaScript events and things like that. But for the most part, in your sort of smooth 60 frames per second world, Blink doesn't really care about it. So if everything went well and the page is well built, then everything will be handled on the IMPL thread. But you'll notice we do still have that fallback. So that's the reason that user input arrow is still going into Blink there. Blink still needs to be capable of handling these gesture events. And these are the cases where we can't composite or we can't scroll on the compositor. And so these can be quite common. So for example, if you have like a weird CSS border radius on your scroller, or more commonly, if you have a low DPI screen and we're doing LCD text anti-aliasing, in those cases we'll actually just throw our hands up and we won't composite. So now we can talk about what's wrong with this picture. It's basically the fact that we have gestures going into these two different places. So they're conceptually far from each other in the code. It's difficult to share anything between them. They run on different threads. So as software engineers, hopefully you already know that duplication is bad and I probably don't need to really convince you. But this is an especially egregious case, I think. Features that deal with scrolling basically have to be implemented in two places, both in the compositor and in Blink. So if you talk to anybody that works on input dev, they'll tell you basically any feature you work on, we have to do two halves of it. This is hugely painful. Some of the features we have in Chrome are inherently compositor-centric. So for example, the over-scroll glow, or like the rubber banding effect on OS X, those are all implemented completely in the compositor. And then overlay scroll bars in Android and Chrome OS are also implemented mostly in the compositor. So this is sad because if you don't have if your scroller is not composited, you won't get that feature. But it's also hard to build out new features. So for example, one of the most requested features we have is having like an overscroll glow for sub-scrollers. And this is really painful to do because you would have to go and do the work twice in Blink and in Compositor. And that's a ton of work and nobody wants to do that. So it's been blocked on this bug. So there's also the fact that we frequently have inconsistencies between the two halves. So this is obviously a bug. Blink and Compositor disagree on behavior. And this can come up in really subtle ways, and it's hard to control in every way. For example, there's differences in how we handle floats and how we do rounding. So these are actually really hard to stamp out. And when you do get a bug, debugging it is actually harder because now first thing you have to do is figure out which half of the divide it lives in, and presumably you might have expertise in one side and not the other. So this is a real challenge. There's some cases where we have to do synchronization between the two threads. This can be really painful. Scrollers can jump in and out of being composited and not composited. If you take a look at the animation code, for example, there's a huge hairy mess of like how do you synchronize an animation between compositor and the main thread. So for example, what do you do when you've got an animation running on the compositor and suddenly your layer disappears? So there's a ton of machinery in there to manage this state. And this is generally a productivity problem. We spend our days looking for the needle in the haystack. This is just making the haystack bigger. I can go on, and I will. Testing is a big pain. We've basically doubled our testing surface area here. Every time you add a new feature, now you've got to do tests on both sides. A lot of our traditional testing pipeline is through layout tests and using Event Sender. So this basically exercises just the Blink half. You could argue the CC half is actually the more important one. Most of Android runs CC, and if everything's going well, the ideal case is that we're actually running on the compositor. The compositor tests are actually quite hard to create. For the most part, you can't just have a little HTML and test the functionality. It's usually unit tests, and they require you to set up a brittle layer tree. You have to know what you're doing in the compositor, and it's very specific. There's cases where somebody will go and change how the layer tree looks, and then your test might still be passing, but your feature's broken. So making testing hard is really bad because then we end up with fewer tests, less comprehensive tests, and then everything is a little bit worse. And we've increased our overall system complexity. So we have more classes, more code, more state, and this leads to more bugs. And it's not trivial code either. If you have a look inside layer tree host impl or the scroll manager in Blink, there's quite a bit of stuff in there. And this is really overlapping responsibilities between Blink and Compositor. It should be one or the other, not both of them. So the solution is naively simple. Just remove the Blink half, right? Well, that's easier said than done. So there's a number of reasons why it's not that simple. So to start, not all scrollable areas are composited. I mentioned before that only some of these will get composited and only in the right circumstances. So for example, LCD text and anti-aliasing, that depends on knowing the color that's behind what you're trying to raster. So we can't do that on the compositor today, so we basically just fall back to Blink and paint everything into the same layer. So CC doesn't know about the scroller, and it can't scroll it, so that's a pretty big problem for us. So the fix is kind of already in the works, and it's basically swimming pane property trees. And scroll tree is really the thing that we want. So what we'll have is Blink will generate the scroll tree and then ship that over to the compositor. So today I think the compositor already has scroll trees, but it generates it based on the layers that it has today. Eventually, Blink will actually be shipping the scroll tree to the compositor. So at least in theory, the compositor should be able to know about everything that's scrollable on a page, even if we didn't get display list for that, or even if there's no layer. So the second problem is that sometimes scrolling isn't just as simple as translating a layer. So this is like, again, the LCD text example keeps coming up. It's probably our most common one. But also things like complicated clip paths can get in the way. Compositor doesn't really know how to do those things. So this is fundamental to the compositor, but I don't think it requires us duplicating the gesture handling paths. We could just teach the compositor that modifying a certain special scroll node just causes a full Blink commit and begin mainframe. This sounds bad performance-wise, but it's really no worse than what we do today. And that's the worst case. But I think we can do better here. So you might have heard this raster-inducing scroll word come around a bunch. CC already receives unrastered display items, and in most of these cases, I think all of them, we don't really need to do a repaint. We really just need to re-raster. So there's a bunch of work. We just heard in the last talk, raster being moved further and further away from the render. So we could actually do a lot of this in I guess the compositor or whatever, wherever it ends up. So today the compositor actually rasters the entire display list, I guess, that it gets from Blink. I'm not sure if it's the whole thing, but the point is it rasters much more than it actually shows on the screen, and then it just translates it up and down. But we could teach it about these new kinds of scroll nodes where instead of doing that, it would actually just raster whatever's visible every time the scroll node changes. So it might also need to do some blending with what's below. So for like that LCD text case, we might need to know about other raster sources, and then so you'll want to combine them. I'm kind of going to wave my hands a little bit here because I'm not a graphics expert, but I have talked to people like Bokan, and he seems to be convinced that this is quite plausible. And I think threaded rendering has already started kind of doing some exploration in this area. So I think things are kind of already in motion. This would also help, I forgot, if you're dragging your scroll bar, for example, Edge does this. So they already have like impulse-side scrolling for scroll bars, which today we just fall back to Blink. The problem there is you can move a scroll bar really, really fast, and that changes your scroll offset really quickly. So they end up checkerboarding excessively when you're dragging your scroll bar. The raster-induced scroll solution would actually fix that, since we would prevent checkerboarding in that case. So that's something we could use for that as well. And then even if we have a scroll tree and raster-inducing scroll, we're still not quite there yet. The compositor can't really hit test in all cases. So if you get a gesture scroll at some position X, Y, how do you know which scroll node we should actually modify? So the scroll tree doesn't have any geometry information. Today we just rely on layers. In theory, you would think the compositor has all these display lists now. We should just be able to hit test there. But it's not the case that everything that you can interact with on a page will actually get shipped to the compositor. So for example, if you have opacity 0 on some part of your tree, as an optimization, Blink might not send that bit to the compositor. So what are we to do in that case? So we expose hit testing from Blink and basically make that a service that the compositor can consume. Really, only Blink has all the details to answer these kind of questions, so it needs to be involved at some point. But we can actually just like split out that hit testing bit. And it turns out that I'm not the only one who wants this. This is important for the Mustache project. They also need to figure out which renderer to send things to. And so this was already in the works, which was a happy surprise for me. So here's basically how that would look. Basically, you would have a gesture come in, and I'm not really sure whether it'd be the compositor or some bit above it. It would go and ask Blink for a hit test, or maybe for things like keyboard, you don't really have a location, but you still need to know which thing you're going to scroll. So it would ask Blink that, and then it would get back, and then it would just go back into the compositor. But we might not even have to do this. So remember I said that there's two kinds of events. First, we'll send like a mouse wheel event to Blink, and then it'll come back, and then we'll send the gesture. So when you get that act from the input event, you could actually package in the hit test result of that, and then just package that with the gesture event. So we wouldn't even have to do an extra hit test. Finally, the last problem is that there are some input modalities that today are implemented in Blink only. So these don't scroll with gesture events, and they're main thread only. So for example, keyboard and scroll bar scrolling work like this. This isn't really an issue in the same way that the other gesture scrolling is, because there's no duplication today. But this would still be nice to do from a design and code help perspective. And so moving these to the compositor, it's quite simple, it's straightforward, but it is a bit tedious. For keyboard and auto scrolling, we would basically have to make them send gesture events. This is the same kind of project that we did for mouse wheels about a year ago, where mouse wheels also used to just send input events and then scroll and Blink. Now they've been converted to actually do this whole input event and then gesture event dance. And we would also have to implement scroll bar input in the compositor. Again, this isn't really urgent to fix, and this could be done as a follow-on work. And really, the compositor shouldn't be in the business of input handling at all. So we would probably want to split input out of the compositor at some point, so this could be something that we wait until we split out the input first and then do this. So how does the end state of what I'm talking about look? So basically, we have a clear division of responsibilities. Blink handles input events, and then the compositor handles gestures. Blink is really the rendering engine, so it's responsible for rendering and producing content, and then the compositor is responsible for interaction and output. So if you remember this picture of the input event coming in, and then the gesture, and then we've got that sort of decision point there, and then forwarding the event, this is how it would look now. I think it's much more straightforward and pretty looking. And we can also remove a bunch of code, which is always nice. Code that doesn't exist is code that doesn't have bugs. It's also code that we don't have to test and maintain. So all the event handling in Blink that uses gesture scroll events would be gone. The Blink scroll manager would be gone, which is about 1,000 lines of code. A bunch of files from page scrolling would also be gone. Anything related to scroll customization, I think that's all user input driven. Over scroll controller and viewport scroll callback, if you've ever seen those in Blink. And probably large chunks of scrolling coordinator too, since there's a lot less to coordinate now. And then there's also features like scroll boundary behavior, which we have to implement twice. We could actually just remove the Blink half of it now, since we could rely on the compositor implementation. So that's basically all I have. I'll open it up for questions and comments, but I'd especially like to know if any part of this I've made it sound easier than it actually is. And if there's any potential roadblockers that you guys might be aware of that I kind of missed here. Yes.
So this is a great presentation. I think it's a great idea overall. I'd like to understand the hit testing story a little better. Like right now we have a duplication where hit testing is implemented in Blink and in the compositor. But it feels like we still need a compositor side implementation in order to not block on main for scroll input.
Right.
How does the hit test service fit into that picture?
So I guess that would basically be the, sorry, did you want to jump in there?
No, I was thinking along those lines, since the hit test request comes in asynchronously to the main thread, what if the tree's in an inconsistent state at the time hit test comes in?
I can answer. So I mean, we do this today already, where when we ship compositor frames, we ship regions that we need to ask the main thread to do hit tests on. So then when we get events on the compositor, if they fall within that region, we know that we need to check whether those input events are handled, that's the thing, or even hit the scroller.
So for things outside that region, we're still going to go to the compositor thread hit testing events.
Right.
Yeah, so I think the hit testing service going to Blink, it's basically a fallback for the case today, where today we would actually go and do the scroll in Blink. So instead of doing that, we would actually go and do a hit test, and then we would go back to the compositor and do the scroll there.
It's also for event handling that we do today.
Okay.
So we ask Blink to handle the input event, or if it would handle the input event, wait for the result. So the thing is, we can basically think of it as skipping the input pass entirely. And we'd be for regions of the page where we know that the Blink thread is, or Blink is not interested in the events. Doesn't mean to handle them in any way. We could go straight to gesture production and target it at a scrolling region.
But then why couldn't the CC and head testing paths are going to stick around? Why wouldn't we just use those for both situations?
Well, they're not accurate. Like we can do rectangular hit testing in CC, but if you have complex things or overlapping things, or
Or compositor also doesn't know about certain things. So if you have an invisible part of the page, but you can still scroll it, the compositor doesn't have anything.
I think someone fixed that bug.
Click mouse, order event.
by
Is it? I thought that was a fundamental part of the slitting pane.
So we just recently introduced these invisible scroll layers. Oh, God,
Okay.
So we basically have these. So the situation is if you have scroll areas that don't contain anything, so the display list doesn't have anything, we just need to create layers for them. So we now do this in SGB2 mode only. We actually create special layers just for scrolling.
Okay.
It sounds like totally crazy, right?
No, I didn't know about that, but that actually might fix
So this is
a bunch of
SGB2
complexities here.
only right now.
Mhm. Yeah, but presumably it's coming, right?
we also fixed this in pre-SPV2 by creating a main thread region for invisible nodes, I believe.
Are y'all working together enough?
Things change so quickly.
Yeah, I mean, this was like 1 week ago.
Yeah.
Take them into the test data that we send is that we actually cross all the groups and send the browser or generalized.
It's a real shame that this stuff has the, like, we have this display list, we just can't hit test on it. That would solve so many things, but I don't think it's possible.
Yeah, we can create a different format.
That's it.
Because you have the inverse, right? You have pointing out to 9. So you have things in your display list that you are visible, but they don't display on your attention.
One of the problems with that's true. Like, it may not be where the receiving region is, right? We can create a SVG filter that moves the display object very far away from where the image are targeted.
Yeah, I think that's the real thing. Anything that can test that.
Yeah, and splash layers versus inverse interesting.
Yeah, I think in the common case though, it would be easy enough to just package back the hit test that we did on the input event. So like if you have a touch start that goes to Blink, we already know what we're going to scroll. there's no point in hit testing that again. So we could just package that back to the browser, and then when the gesture comes in, just reuse that. If we fall back to a slow path and like those kind of like really edge cases where they're doing something crazy, maybe that's not the worst thing in the world.
So this is a directly related question, but do you know what percentage of website is using passive event listeners? So because the main thread is using a normal input event handler, and that may call event default. In that case, the scrolling must be blocked by the JavaScript execution. So I'm wondering, so what percentage in the cases where the compositor can just scroll the page without involving the main thread?
Yes, we have stats on that. Rob, do you know about what percentage of scrollers are handled on the compositor?
It's roughly 50% overall.
Depends on the platform, right?
It depends on the
Depends on
platform.
the platform,
Yeah.
the modality that you're using.
Yeah, so on Android, I think we composite basically everything. And so in that case, you're pretty much always scrolling on the compositor thread. On desktop, if you have a little DPI, which a lot of monitor, which a lot of people do, anything that's like an iframe or a div for the most part, I think will be scrolled on the main thread, unless they have like a transform or something like that.
So if everything on Android is positive, does that 50% number mean that on desktop it's like 10%?
I'm trying to remember the breakdown. I don't recall.
Desktop scrolling is really slow.
Yeah.
Right, because of a few problems you have. Scroll bar, right? People use scroll bars, those are all main thread. You have wheel events, which are all, they all go to the main thread, and then they are handled on the compositor.
I think 50% is the worst case and the average case.
Oh.
50% scrolling on main thread happens only in this.
Oh, I see.
It's different.
And wheel events, they'll only go to the main thread if you have non-passive lists.
Right, and Sahal's working on latching, which Dave called out. That's that we're going to only send the first wheel event to the main thread, and then the rest of the wheel events are going to go as essentially passive events.
We're also working on actually having regions for wheel events rather than
Yes.
globally marking the page as there's a wheel event listener somewhere.
Will latching fix the problem where I do a touchpad fling and I hit control and it starts zooming? That plagues me all the time.
You just don't have to do that.
I have that problem, but I think it's a problem with the like Linux touchpad driver because it's not an actual fling. I don't think that happens on Mac, for example, does it?
No, it's only on Linux.
Yeah, so on Linux we don't have a fling event. So as far as Chrome goes, you're actually just wheel scrolling a whole bunch.
Right, but if we have latching, we have some kind of a gesture.
Aren't we going to create synthetic gestures?
I guess, yeah. So I guess that would
So
at least we could fix it in that case.
Yeah.
Yeah.
It may not be less than all the.
It's not
Sure.
all info, but we have like a timeout.
Yeah. we can fake it.
There's a reason why this Chrome OS sequence is much more complicated than X.
No, I realize, but we can fake it with timing and stuff.
Yeah.
For JavaScript scrolling, yes, we also create synthetic gestures, or do we directly call to some scroll manager? And then if so, how do we handle those?
So JavaScript doesn't have like a notion of actually like user scrolling, so it basically will just update the scrollable area, scroll offset. So I don't think it has to go through the scroll manager at all. Yeah, I think it just updates the. Unless you know otherwise, then please tell me.
Isn't scrolling to view if necessary have an option for animating?
Yeah, but it doesn't generate a gesture.
Yeah, it's no gestures. It just creates an animation curve, and then we update the scroll areas. And then I think those can still get moved to the compositor. Right? That's that. Yeah, that's that whole like synchronization machinery for animations. Okay, I think we're about out of time. But yeah, come find me, talk to me, let me know if any of this sounds really crazy. Thanks, guys.